Hi everyone, it's me Indra. Welcome back to my channel. Today in this video I am going to solve a limit related problem which was asked in IIT Jee examination in India. Please watch this video till the end so that you will be very clear about this very important complicated limit related problem as well as some basic ideas of the limit calculation of a function. And if you don't subscribe my channel yet, please subscribe it and press the bell icon for instant notification of the uploaded videos. Without wasting any further time, let's get started. Here I have taken a question: limit n approaches to infinite. This is the question: n approaches to infinite of the function n times 1 plus 1 over n raised to the power of n minus e n. Here the E is the Euler number, and the Euler number is defined limit n approaches to infinite 1 plus 1 over n raised to the power of n. Please memorize this formula. It is the formula, it is the expression for the Euler number. It is the definition of the Euler number when the variable approaches to infinite. It is the infinite case, and when the variable approaches to 0, then this will be the definition of the same Euler number. If the variable approaches to infinite, then apply this condition. If the variable approaches to 0, then apply this second condition. These two are the definitions of the Euler number E. And the next one is here, the expansion of ln of 1 plus x. The expansion of ln of 1 plus x is here written as x minus 1 over 2 times x square plus 1 over 3 times x cube minus 1 over 4 times x square plus and so on to infinite. Here the signs are taken alternatively, here plus minus plus minus. This is the expansion of ln of 1 plus x. Please memorize this formula also. And another one is here the number a can be written as in terms of the logarithm e raised to the power of ln of a. Here the ln means the natural logarithm. This is important property of the logarithm. And the next formula related with the limit x approaches to 0 of the function e raised to the power of x minus 1 over x gives always 1. Please memorize this formula which helps to solve this particular question. And this expression 1 plus 1 over n raised to the power of n when the n approaches to infinite is just the Euler number. So our expression will be n times e minus n times e. And here our variable n is approaching to infinite, so infinite minus infinite case. When we substitute the n as a infinite, then the form will be infinite minus infinite case. Infinite minus infinite form when n approaches to infinite. This is in the form of infinite minus infinite. And let's solve this particular question by using this formula. Please memorize this formula. Here this is our target question, limit of this function. And first step is, here is the n in this first term and n in the second term also. So taking n as a common, limit n approaches to infinite, taking n as a common. After taking n as a common, our expression will be 1 plus 1 over n. It is raised to the power of n minus the Euler number. Here in this step, we just take n as a common from these two terms. And limit n approaches to infinite, and here n, and we already studied on very important property of the logarithm. Let me show this formula. The number a can be written as e raised to the power of ln of a, e raised to the power of ln of that number. Let's make this form in that same format. Let me write here. This can be written as this number 1 plus 1 over n raised to the power n. It can be written as e raised to the power of ln of 1 plus 1 over n raised to the power of n. This is same, ln and in e will be cancelled it out. Our expression will be same, minus e. Here we just write this number 1 plus 1 over n raised to the power of n. This expression is exponential form. And limit n approaches to infinite n times here in these two terms we can take e as a common, e as a common, but here is no e present, single e present. We can make here this expression is a e raised to the power of ln of 1 plus 1 over n, it is raised to the power of n minus 1. Here we take e as a common, so we have to here do the minus 1 because it has no single e, so we have to give its power as a negative 1 minus this will, this e goes to here is a common, so here is only 1 remain minus 1. Here you just take the e as a common from these two terms, this is just minus 1. And let me simplify this. Limit n approaches to infinite, n times e, e is here Euler number, and I am going to make this expression, this expression, let me write here, I am going to make this expression, enclosed expression, in the form of this limit x approaches to 0 of this e raised to the power of x minus 1 over x, and here uh, here the in place of x, in place of this x, here is just ln of 1 plus 1 over n raised to the power of n minus 1. In place of x, here is this term, in place of x, here is this term minus 1 over x. We need here the dividend is a this term, so putting the denominator, let's do the some modifications on the expression. This can be written as e raised to the power of ln of 1 plus 1 over n raised to the power of n minus 1 minus 1. Let's divide this by this expression, this is a x, and let's divide ln of 1 plus 1 over n raised to the power of n minus 1. Here we just divide this expression by this quantity, and we have to multiply by the same number to balance the expression. So ln of 1 plus n raised to the power of n minus 1. Here we just divide and multiply by this expression. I am going to use this formula, and here in this formula this exponent is here x, and the east approaches to 0. Let's check here this expression, this term approaches to 0 or not. When n approaches to infinite, 1 over n 0, ln of 1 0 0, ln of here this will approach to, when n approaches to infinite, then this will approaches to the 0, this will approaches to 0. So we can apply this formula. This can be written as, this term can be written as a 1. So our limit will be limit n approaches to infinite, n times e, and this will be 1 times 1. These whole expressions will be 1 by using this formula. So the 1 times remaining expression ln of 1 plus 1 over n, it is raised to the power of n minus 1. Let's simplify this expression, and this can be written as limit n approaches to infinite, n times e, and here the ln of, and this can be written as, this power will come in the front by using the property of the logarithm, and the ln of 1 plus 1 over n minus 1. Here we just use the formula log a raised to the power of n is just n times log a. Here we just use in the system, and let's simplify it. N approaches to infinite, n times e, and we have the formula for the expanded form of the ln of 1 plus x. We already discussed. Here the ln of 1 plus x, ln of 1 plus x can be expanded by this form. So we are applying this concept in this system. Let's apply. Let's apply this expansion of ln of x in this system. Let's expand it. This can be written as this can be expanded as x, here the in place of x here is 1 over n, 1 over n, and then minus 1 over 2 times e square is 1 over n square, and then plus 1 over 3 times 1 over cube minus and so on. Here you just expand this ln of 1 plus n, and this is minus 1. Here in this step we just expand this ln of 1 plus n by using this formula, and let's simplify it. Limit n approaches to infinite n times e of, and here inside this we can multiply, we can distribute this n among all the terms of this infinite series. Let's distribute this n, let's multiply by this n, and then 1 minus, if we 1 minus this will be 1, if we multiply 1 over 2n plus 1 over 3 n square and so on, and this is here just negative 1. Here we just multiply this by this n to each terms of this infinite series, and then here the positive 1 negative 1 will be cancelled out, and the limit n approaches to infinite, and here is the extra n, let's multiply by this n also, e times, if we multiply this n by 1 over 2 plus just multiplying by this n to each terms of this infinite series, and now 1 over 3n minus 1 over 4n square plus and so on to infinite. Here we just multiply by this n to each terms of this infinite series, and limit n approaches to infinite, this is e, and if we put, let's use the, here the e, the number e is the constant number, so we can take it as a coefficient. So let's no necessary to give the limit to the constant. This is e times the limit of n approaches to infinite of this 1 over 2 plus 1 over 3n minus 1 over 4 n square and so on to infinite. And this can be written as e times, and if we approach the n as a infinite, if we put the n as a infinite, then this will be 0, this will be 0, 0 plus 0. All the terms after this first term, all the terms approaches to 0. So this will be just negative 1 by 2, and this is just e, negative e over 2. This is the final answer of this question. Here in this step we just approach n as a infinite, and these terms after the first term will approaches to 0, so the negative 1 over 2 will remain. E times negative 1 over 2 gives negative e over 2. This is the final answer of this particular question. Finally we solve this question by using this concept, by using this formula. We finally solve it, and the answer is, the final answer is negative e over 2. Final answer is negative e over 2. This is the final answer of this question. This is very complicated problem on the limit. In our next video we will discuss more about the limit calculation of a function. Please keep watching, keep loving this channel. This much for today. Thank you.